Last spring we were online, and again this spring we are online. And what I wanted to do was put a little bit of an intro into this chapter 20. It is the last true chapter of Gen Chem that we are going to do. There's nuclear, there's coordination chemistry, but electrochemistry is essential in many, many different areas. On the left, you see things we normally see in class. We're going to explain the redox process, we're going to explain the table, and we're going to explain how E and G and K can all be related on paper. Well, then on the right is where these things are being used. Right now, I'm using my iPad to send you this recording, and you also have a cell phone. Sitting on the bottom is an EKG, and you've probably seen one either in person, on TV, or who knows wherever. But again, this is all based on the principles we're going to talk about of electrochemistry. So again, this is the chapter that probably is most like real life. We've got the EKG there, and what this is on the y-axis is a voltage. What I wrote there, microfluidic devices driven by rat muscle cells. Right now our heart is beating, and that is because of potassium ion going in and out of the cell membrane. But they've been able to make devices using muscle cells that can do the exact same thing. The other important point in this chapter is searching for a better battery. You know, solar and wind are really being debated as clean alternative energy sources, but you need to be able to store that energy, and that would be probably for a physics or an electrical engineering course, but have to mention it out loud. The lithium-ion battery that we find in various forms in our devices was developed in 1991. Since then, the changes have been incremental. If you've paid attention to the news, you see that GM is going to switch to electric cars in I would say, the near future. The real problem is, where are they going to get the lithium? It was just in the Wall Street Journal that we primarily get it from China, Australia, and they're kind of holding everyone else captive. They're trying to develop stores of it in North Carolina. There was also recently an article, but it's very expensive to mine. It comes with silicon and aluminum as an oxide, and then you have your environmental problems about getting rid of the waste. Again, these are big issues. These are not minor issues. Fuel cells kind of come in and out of vogue, but you might be surprised because they were around in 1839. So again, a little bit of historical perspective to some very fundamental principles we'll talk about in this chapter. Electrochemistry is the topic, and what it did is it gave people knowledge of what was going on in a chemical reaction. You've sat through Gen Chem for an entire term and you've said, like, where does this come from? How does this work? Well, when people went in the lab and they identified the ions, which in itself was a task, they worked backwards to elucidate the chemistry. I just think that's really interesting. I'm sorry, that's really what makes me interested in this area. So this chapter is going to give you a relationship between electricity or electrochemistry and chemical reactions. It is pretty interesting. You've already learned about spontaneous, that's a negative delta G, and non-spontaneous, which is a positive delta G process. And that power has been harnessed, to produce batteries. So that's primarily how we think about it. But you can also use electricity or electrochemistry to drive a chemical reaction that you do want. Electroplating. If you have a metal and you want to plate something on top, you use electrochemistry, but also it's important to understand things are not desired. If you live in Cleveland, the bridges down in the flats are a perfect example. I think in Cincinnati they're in better shape. But you want to prevent corrosion, and that's, we need a new infrastructure in the United States. So I can't think of a better chapter as we're making our way through Gen Chem, kind of to be our last big chapter. So what I did is, as usual, I wrote down the problems that you really do need to work. You will not really understand this until you apply it. I know I've been saying this kind of since chapter 1 in 1210 for those of you that are with me. And as we are finishing up this course, that is how you use the material. When I worked in industry, I hired people based on their ability to solve problems. I assumed they would come in with the knowledge. What I needed to do and my company needed to do was show them how we do things and let them take off to solve problems. So again, I'm hoping that your attitude is still good. We're in the midst of a pandemic this semester, and we're going to finish strong. So It's tough, but sit yourself down, work these problems. Most of all, ask questions. I just read an email where someone said they kind of get to a problem and they vacillate back and forth. What's the right answer? You want to know the right answer because that's what's going to push you along in your career. Remember, where you are today measures where you are today. It does not measure where you can possibly go.